Welcome to The Explainer. Today we're doing something incredible. We're literally shrinking down to the cellular level to explore what is arguably the most intense, microscopic battlefield on Earth, your own body. Seriously, every single day there is a hidden war raging inside you. And your survival? Well, it completely depends on a dual army working with absolute precision. We are talking about the human immune system.
To really grasp the magnitude of this system, let's actually look at where the word itself comes from. The term immunity originates from ancient Rome, where it referred to a privilege that exempted individuals from certain obligations. Essentially, biological immunity is exactly that. It's like having an ancient VIP pass against disease. Once you have it, you're exempt from the illness. But how exactly does our body earn that VIP pass in the first place?
Well, here is our roadmap for today's explainer. We'll start with number 1, the body's defense system. Then 2, innate immunity first responders. Followed by 3, lymphoid organs, command centers. And finally, 4, adaptive immunity, special forces.
All right, let's kick things off with Section 1, the body's defense system, setting the stage.
Okay, let's dive into this. Functionally, our immune system employs 2 main lines of defense. First up, we have innate immunity. Think of this as your immediate response. It acts fast, usually within 12 to 24 hours of an infection. It's nonspecific, meaning it targets common features of microbes, and, critically, it has 0 memory. It reacts the exact same way every single time. Then, on the other hand, we have adaptive immunity. This system kicks in after that 24-hour mark, which is usually when you actually start feeling sick. But it is highly specific to particular antigens, and it develops long-term memory. This means if you encounter the exact same threat years later, the adaptive system remembers it and mounts a vastly more rapid, incredibly potent attack. And looking at how this is all structured beautifully illustrates where all these defensive units actually come from. We're looking at the incredible family tree of the immune system. Right at the very top is the multipotential hematopoietic stem cell, or hemocytoblast if you want to save some syllables, located deep inside your bone marrow. From this single shared origin, the family splits into 2 main branches. You have the myeloid progenitor, which gives rise to our innate infantry like neutrophils and macrophages. And then you have the lymphoid progenitor, which generates our adaptive special forces, the B and T lymphocytes.
Moving right along to Section 2, innate immunity, first responders. So before our immune cells even get involved, the body relies on pre-existing physical and chemical blockades that act as a literal wall against pathogens. Your skin and mucous membranes? That's your physical armor. Chemically, an acidic pH creates a super hostile environment for microbes. Then we have our natural biochemical weapons, things like lysozyme, which is an enzyme found in your tears and saliva that literally breaks down bacterial bonds, causing them to just burst, and defensins, which aggressively punch holes straight through the membranes of invading bacteria and viruses. Now, if a pathogen actually makes it past that wall, it meets the neutrophils. These are the most numerous granulocytes in your blood. We're talking 40 to 80% of your white blood cells. And their tactics? Absolutely brutal, and honestly fascinating. They only live for about 6 hours to 3 days, making them a highly expendable frontline infantry. To stop invaders, they can cast out neutrophil extracellular traps. They literally act like Spider-Man, throwing a web to ensnare pathogens. Or, if things get really desperate, they execute a kamikaze attack. They forcefully release all their toxic granules to obliterate the enemy, completely destroying themselves in the process. Let's look at the minute-by-minute ticking clock of this innate escalation as your body desperately tries to contain a breach. At 0 minutes, pre-existing molecules are immediately active. By hour 1 to 2, your blood vessels dilate to let immune cells rush through. At hours 4 to 6, those kamikaze neutrophils and the larger monocytes swarm the tissue. By hour 8 to 10, chemical signals trigger the hypothalamus to induce a fever, literally turning up the heat on the invaders. And by hour 12, the liver kicks in, pumping out acute phase proteins to supercharge the cleanup effort.
So the absolutely crucial point here is, how is all this chaotic frontline action actually coordinated? Well, the answer is cytokines. Cytokines are tiny proteins, just 15,000 to 20,000 Daltons, that function as rapid, short-lived radio signals. They mediate and regulate the entire immune response. They are the essential communication network, calling for backup, telling blood vessels to dilate, and directing the troops exactly where they need to go.
Let's take a breath and move to Section 3, lymphoid organs, command centers. We are moving away from the chaotic frontline now into the secret geographical bases of our immune system, the infrastructure of our immune command. We have two main types of lymphoid organs. First are the primary or generative organs, specifically the bone marrow and the thymus. Think of these as the boot camp. It's where immune cells are born, undergo intense education, and acquire their specific receptors. Then we have the secondary or peripheral organs, like the lymph nodes, spleen, and MALT, which stands for mucosa-associated lymphoid tissues. These are the active deployment zones. This is where mature cells wait to actually encounter foreign antigens and mount a targeted defense.
Take the spleen, for example, which is the largest lymphoid organ in the entire body. It's not just a passive sac. It's a massive blood filter and macrophage processing center. It performs crucial immune surveillance, actively hunting down circulating antigens. It also executes something called hemoketoresis, which is the highly specialized removal of aged 120-day-old red blood cells, all while actively filtering out defective pathogens and immune complexes from your bloodstream.
And that brings us to our final act, Section 4, Adaptive Immunity, Special Forces. But before these special forces can strike, they need to know exactly what the enemy looks like, right? Enter the MHC, or in humans, the HLA system. Think of the major histocompatibility complex as a biological wanted poster. Special cells capture the invader, process it, and display a tiny piece of it on their surface using these HLA molecules. Without this incredibly precise ID badge system on our cells, the adaptive T-cell special forces would be completely blind. They wouldn't know exactly who to target.
Now, what's really interesting about this slide is how our two special forces units engage their targets completely differently. First, we have T lymphocytes. They rely heavily on those HLA wanted posters. You've got the CD4+ helper cells that act like field generals, coordinating the attack with cytokines, and the CD8+ cytotoxic cells that execute the lethal kiss of death directly onto infected cells. On the flip side, we have B lymphocytes. They are incredibly unique because they can bind directly to the native antigen without needing an HLA presentation at all. And their main weapon? Producing highly specific antibodies. Let's look at exactly how a B cell goes from a quiet, patrolling guard to a massive antibody factory. It is a brilliantly elegant, multi-lock mechanism to ensure we don't misfire. Step 1. The B cell binds the raw antigen and pulls it inside. Step 2. It chops it up and presents it on its own HLA-2 molecule. Step 3. A T helper cell comes along, inspects it, and locks on to exchange signals. Step 4. The T cell releases activation cytokines. And finally, Step 5. Clonal expansion. The B cell rapidly clones itself into a massive army of plasma cells, pumping out millions of targeted antibodies to clear the infection. As those B and T cells finish their job, some actually stay behind as memory cells, ensuring that if this exact enemy ever returns, they're neutralized before you even feel a single symptom. Which brings us to a fascinating final question for you to ponder. If our adaptive immune system creates these hyper-specific memory cells to prevent illness upon reinfection, how do we ever get sick twice? Think about how viruses might mutate their surface proteins, or how our own memory cells might just fade over time. Thank you so much for joining me in this explainer today. Keep asking questions, and I hope you leave with a newfound appreciation for the incredible, microscopic battles keeping you alive right now.